Hello friends, welcome to my channel PSU Aspirants. In this video, I am going to discuss buck converter completely from GATE and ESE exams questions point of view. In GATE exam syllabus, buck is the first DC to DC converter out of 3. So friends, let's start with the first converter, that is buck converter. Its function is to step down the input DC voltage to some low value. Hence, output of the buck converter will always be less than or equal to the input voltage. So let's start with the circuit of buck converter. It is a circuit. In this circuit, Vs is the input voltage source. S is a switch, high frequency switch, which gets on and off at very high frequency. It is used to charge an inductor which is connected to the load, that is with the help of capacitor C. This capacitor C is used to decrease the ripple in the output voltage. The average output voltage which is appearing across the load is V0 or V0. This diode is used for freewheeling whenever this switch gets off. Hence, this inductor gets passed through the diode when the switch is off or disconnected. Now friends, we will define a parameter called as D is duty cycle, which is equals to the on time of the switch divided by the total time. So, the off time of the switch will be given by T total time minus on time equals to T minus dt. So total off time is equals to T total time into 1 minus D, and the on time is equals to dt. Please remember it as it's very important basic concept of DC to DC converters. Let's see on the waveform. So this is the switch. Whenever it gets on, so it gets on for the period of t equals to 0 to t equals to dt, and it gets off for the period dt to t, that is t off. Here we have divided the circuit of the buck converter into two parts, when the switch is on and second when the switch is off. So first, when the switch is on, let's see the circuit. This input Vs appears across the inductor and it is positive in nature, so this diode gets reverse biased and it gets eliminated out of the circuit, and the output voltage V0 appears across the another terminal of the inductor. Hence the inductor starts charging. Similarly, when the switch is off, so the inductor finds a path through this diode to discharge its IL, inductor current. Let's see the waveform of the inductor current. Whenever it is charging during the on time, the inductor starts charging from the value IL min, that is minimum current, to maximum current IL max, and whenever the switch becomes off, it starts discharging from the maximum value of IL max to original IL min value that was at the start of the cycle, and the cycle gets repeated. So friends, now we will find the basic parameters of the inductor which are used in the competitive exams for solving the problem. So first, let's start with the voltage across the inductor VL. Whenever the switch is on, the voltage across the inductor can be given as V plus minus V minus at any instant. That is voltage across this positive terminal minus voltage across the negative terminal, for which we have assumed the polarity. So it is equals to during on time the voltage across the positive terminal is Vs, and during on time the voltage across the negative terminal is V0. So voltage during on time will be Vs minus V0, and it is positive in nature because we will derive soon that V0 will be always less than the Vs. Hence, as the voltage is positive, the inductor was charging, and during the off time of switch, the voltage across the positive terminal will be 0, because we have considered idle diode. So for idle diode case, the voltage at this positive terminal 0 and voltage across the negative terminal will be V0. So off voltage will be equal to 0 minus V0, that is equals to minus V0. Hence the voltage across inductor is negative, so it discharges during the negative cycle. Friends, let's start with the second parameter, that is V0, output voltage, in terms of input voltage, that is Vs. So how we will derive? We will use the charging equation of the inductor, that is VL equals to del IL divided by del T. During the on condition, the del T will be equals to dt as discussed previously, and the del T during off condition of the switch will be equals to 1 minus d into T as discussed previously. Now del IL, change in inductor current during the on period, that will be given by, this is the on period. So in this period, the inductor current at the end of the on period is IL max, and at the starting it is at t equals to 0, it is IL min. So the change will be IL max minus IL min, that is I max minus I min equals to del IL, that we will describe as del IL. And during off condition of the switch, the inductor discharges, current falls. So the change in the inductor current will be given by, at the end of the off period t, the current final is I min and initial current was IL max. So the current will be given by IL min minus IL max equals to minus of del IL. Let's apply the charging equation of the inductor. So during the on time, VL on was Vs minus V0 equals to L into del IL divided by T on, that was dt. So Vs minus V0 into dt equals to L into del IL. That becomes equation number A. So during off time, VL off was minus V0 equals to L into del IL. During off, it was minus del IL divided by 1 minus d into t, that was del T off. Therefore, this minus minus gets cancelled, and V0 into 1 minus dt becomes equals to L into del IL, that is equation number B. So comparing this both equation and removing this del IL term common one, we get Vs minus V0 into dt equals to V0 into 1 minus dt. This t gets cancelled, and the finally after solving we will get V0, that is output voltage of the buck converter, equals to d times of Vs. Vs is the source voltage, as d, that is the duty ratio, T on divided by total time period, will lie between 0 to 1. Hence the output voltage will always be lying between 0 to Vs. It can never be greater than Vs or source voltage, as maximum value possible of d is 1. The third basic parameter, that is del IL, or ripple in the inductor current. So previously, as discussed, for switch on condition, the charging equation was Vs minus V0 equals to L into del IL upon T on, that is dt. So del IL, this term, that is ripple in the inductor current, equals to Vs minus V0 into dt upon L. Now this is the fundamental equation which will be applied to any problem of the buck converter for ripple. Now you can manipulate according to the values or problem given. So if V0 is as derived is dVs, and this time period t is 1 upon f, frequency of switching. So del IL, ripple in the inductor current, will be given by Vs into 1 minus d into d upon FL. I have put V0 equals to dVs. So and then taking Vs common out of this bracket, it becomes Vs into 1 minus d, this whole thing, into d, and this t I have goes in denominator due to this formula, and we finally get this equation. So very important thing we have concluded, that is del IL, ripple, is inversely proportional to the value of inductor used in the buck converter. So in gate problems, it will be given that assume very large value of inductor L, very large. So L tending to infinity, so del ripple in inductor current will be 0. So the inductor current waveform will be reduced to this third, that is with the time 0 to t, the IL, inductor current, will be constant. It will be 0 ripple, so it will be constant over the whole time period. Okay, it is given in many gate problems that ripple assuming neglecting the ripple current. That is the waveform of IL. Now let's start with the fourth parameter, that are IL max, IL min and IL. This is the IL max, this is the IL min, and the average value of this inductor current over the whole cycle is IL. So let's start. So I have here drawn at the end the waveform of the capacitor current. This is IC. So let's examine this waveform. During the on time of the switch, IC on can be given by IL minus I0. Let's see how it is. During the on time, this is IL, current through the inductor. This is the capacitor current. Some portion goes into the capacitor, and some portion goes into the load of the IL. So we can write by KCL that IC equals to IL minus I0. Now during the off condition, same thing still happens. Inductor is discharging in this direction only. That's why IC will be still equals to IL minus I0. Now we can see that for the stability of this capacitor, the net charge taken by it during the positive cycle would be equals to the net charge released by it during the off cycle or the negative time period. That's why, and applying the ampere second balance, IC on into T on plus IC off into T off equals to 0. Hence the net charge gain or lose by the capacitor over the total time period will be 0. So IL minus I0 into dt plus IL minus I0 into 1 minus dt equals to 0. Hence by solving this equation, we will get IL, the average value of inductor current, will be equals to I0 or equal to load current for the buck converter. That's very important result. Now we have derived the value for the ripple del IL previously in third point, that was equals to Vs minus V0 d upon FL. Hence the value of IL max. Let's find now IL max and IL min. So we can see that for this triangular waveform, the average value which we will get will always lie between or in center of IL max and IL min. Hence the IL or this del IL, difference between IL max minus IL min is del IL. Therefore IL above IL, it will be, if we add del IL by 2, then we will get IL max, and if we subtract del IL by 2, we will get IL min, as because it will lie in center of IL max and IL min. That's why IL plus del IL by 2 will be IL max, and IL minus del IL by 2 will give us the IL min. Therefore IL min equals to IL minus del IL by 2. Let's start with the fifth point, that is source current IS. We'll find its average and RMS value. So when the switch is on, the source Vs will charge the inductor and it will deliver the source current Is equal to the inductor current for time 0 to dt only. Now as soon as switch is turned off, source is isolated from this whole circuit, hence the power or current delivered by the source during time dt to t of time will be equals to 0. Hence let's start with the average value of the source current. How to find it? It will be equals to, but let me tell you one thing, that whenever the problem will come to find any of this current, source current, switch current or diode current, they will tell you that inductor is very large, hence you have to consider ripple equals to 0. So the waveform of inductor current IL which we are going to use will be this one. Hence we will keep this waveform as our main aim, and with the help of IL or in terms of IL we will determine all this current for all these problems in gate or ESE. Let's start with the IS now. Is will be equals to average value of the source current. It will only flow for 0 to dt time, and it will be equal to IL into dt, time for which it is flowing, divided by total time. Hence the source current, average source current will be equals to IL into D, and RMS value of the source current, it will be the root of mean of square of root mean square value it is. So IL square into the time for which it is flowing, that is dt time, and total time, that is t. So we will solve this, we will get source current RMS value will be equals to IL into root D. Now how we will get the value of IL if the problem is given? In the problem they will give you output voltage, suppose 20 volt and resistance equals to 5 ohm, like that they will give. So we have derived that IL was for buck converter, value of IL, average value of load average value of inductor current is always equals to load current, that is equals to V0 by R. So we will put that and get the value of IL, and then substitute in these two equations of source current and we get average source current, and with this equation we can get RMS value of source current. Start with 6th parameter, that is switch current, average and RMS value, if question is asked like that. So we can see that switch current, that is here. So whenever the switch is on, current will flow through the switch, but when the switch is off, it will not flow, current will not flow through the switch. Hence we will give the waveform of the switch current like this. For on period it would be inductor current, same as the inductor current, and for off period it will be 0. So it is similar to the previous case of source current only, that when source was getting isolated in the off time. So everything is similar. Average value of switch current will be IL into D, and the RMS value of the switch current will be equal to IL into root D. And how we will get the value of IL if buck converter question is that is equal to I0 equals to V0 by R. Start with the 7th parameter, that is diode current, if it's asked in question exam. So we can see that whenever the switch is on, the diode is reverse biased and it does not conduct any current. But when switch is off, so the diode gives the path for discharge of the inductor. Hence the diode current during the off time is same as the inductor current. So this IL during the off period will be coming in this diode current waveform for off time as ID equals to IL for off time, but in on time of the switch diode current will be 0 as it is reverse biased. So this is the waveform of diode current, and now let's find its average value first. So ID for the diode current average value will be equals to IL, and for how much time it is coming, it is the time is 1 minus dt off time or divided by total time. That is the average value formula, that is current into the time for which it is flowing divided by total time. IL 1 minus dt divided by t. So this gets cancelled and the average value of diode current ID becomes IL into 1 minus d. RMS value of the diode current, so it will be equal to mean of IL square into time for which the diode current is flowing 1 minus dt divided by total time. It gets cancelled and the RMS value of diode current becomes IL into root of 1 minus d. We know that for questions we will use this formula, that IL equals to I naught equals to V naught by R. Now let's see the 8th parameter, that is ripple in the output voltage. Now capacitor voltage Vc is same as the output voltage, hence del V naught, change in output voltage, is same as a change in capacitor voltage. Now the waveform of current through the capacitor I have drawn here. As capacitor does not gain any charge during whole cycle 0 to t, the positive cycle area will be same as this negative cycle area. Hence both the time period will also be same. Positive time period will be equal to t by 2 and negative cycle period will also be equal to this 2 negative sum will also be equal to t by 2. And the peak during positive cycle will be equal to del IL by 2. This part will be absorbed by the capacitor, and the negative cycle peak will also be equal to minus del IL by 2. Hence the charge gained by the capacitor, if we see during positive half cycle, QC plus will be equal to half into base into altitude. So base is how much? T by 2 into altitude, that is del IL by 2. So the charge gained by the capacitor during positive half cycle is equal to del IL upon 8F. Now we will use the following formula. Q is always equal to CV. Therefore del Vc will be equal to del QC upon C. So the change in output voltage will be same as change in capacitor voltage will be equal to del QC upon C. Hence it will be equal to del IL upon 8FC, and finally substituting the value of del IL which we derived, we will get the final result, that is equals to del V naught is this Vs 1 minus d into d upon 8F square LC. Now 9th parameter is the duty cycle required for maximum ripple in the output voltage. So the output voltage derived earlier can be written as del V naught equals to k into d into 1 minus d, because this term, whole term Vs upon 8F square LC is constant k. I have denoted by k. So for maximum del V naught, we differentiate this equation with respect to duty cycle and it should be equal to 0 for maximum condition. Therefore k into 1 minus 2d will be equals to 0. So the duty cycle which we get is half. Now let's go to the 10th parameter, and it's very important two parameters which are asked in GATE examination, that is L critical and C critical. Critical, let's understand what is critical inductance L first. This is the waveform of inductor current. This is the waveform of inductor current. So I told you earlier that the inductance ripple in inductor current del IL is inversely proportional to the value of inductance, right? So whenever the inductance, if I decrease the inductance, then ripple increases. So suppose first it was L1, now I decrease the value of inductance to L2, so the ripple increased but graph shifted below. Now if I still decrease the value of inductance to such a value, this is the third graph, that IL minimum value of current, this minimum value of current becomes 0, that is I minimum equals to 0. Then at that value of inductance at which the minimum value of current becomes equal to 0 is called as critical inductance. So, and if further I decrease the inductance still further, then the current will decay to 0 before the completion of the off cycle. So this buck converter will enter into the discontinuous mode of operation if the inductance value is less than the critical value of inductance. But for upper two cases, 1 and 2, as L1 and L2 are greater than critical inductance, these two are continuous conduction mode, and this fourth one is discontinuous conduction mode. Now IL mean, as we know, is equals to IL minus del IL by 2. So we know that IL is equals to I naught for buck converter is equals to half into this is whole del IL. Now I naught is equals to V naught by R and V naught is equals to dVs upon R. So substituting this equals to this 1 upon 2 Vs d1 minus d upon Fl, we will get the value of inductor L as L critical equals to R into 1 minus d upon 2F. It is very important concept. For L greater than critical value of inductance, it is continuous, and for L less than critical value of inductance, the mode is discontinuous mode. Now the last parameter, that is critical capacitance. For C crit, minimum voltage across the capacitor is 0, as in inductor it was minimum current was 0. So Vc minus del Vc by 2 is equals to 0. We know that Vc is equals to V naught. So V naught is equals to del Vc by 2. This is all is del Vc. Vs d1 minus d upon 8 f square Lc into C. So by that we get the critical capacitance as 1 minus d upon 16 f square into L. But here we have to see that L is the critical capacitance Lc, that we have to consider in every formula. This also, here it is Lc. So Lc is R1 minus d upon 2f. By that, substituting in this equation, we get critical capacitance equals to 1 upon 8 Fr. At last, let's take the summary of what we learned in this video. So first, we learned the basic parameters, all of them we calculated, and that was first VL. VL during on condition is equals to Vs minus V naught, and during off condition it was equals to minus V0. Second thing was the output voltage, which is equals to D times Vs. Third thing, we calculated ripple in the inductor current, that was equals to Vs minus V naught into D upon Fl. We can also simplify it to Vsd into 1 minus d upon Fl. Fourth thing was the inductor current IL, that we calculated using ampere second balance, was equals to I naught, and the maximum and minimum inductor current, that was equals to I naught plus del IL by 2 and I naught minus del IL by 2. because IL is equals to I naught. Fifth thing was the source current, and that is equals to IL into D. Sixth thing, that was switch current. Average current is becomes IL into D, and RMS switch current is equals to IL into root D. Seventh thing was the diode current. Average current becomes IL into 1 minus D, and average RMS diode current was IL into root of 1 minus D. In all of these three currents, we have used common thing of inductor current, so which we can calculate it by using this formula IL equals to I naught for buck converter, and get all the currents very quickly for numericals in GATE. Now, eighth thing was ripple in the output voltage, that is same as the change in the capacitor voltage, equals to Vs d 1 minus d upon 8 f square LC. And the 10th thing which we learned was L critical and C critical. Critical value of inductance R into 1 minus D upon 2F, and for L greater than critical inductance the mode is continuous, and for L less than critical inductance the mode is discontinuous for buck converter. And similarly, the critical value of capacitance we calculated as 1 minus D upon 16 f square LC, and substituting the value of LC, if it is given, if the question in the question the value of resistance is given, then we can directly calculate it as 1 upon 8 FR. So friends, please take the screenshot of this summary. It will help you during your revision time. And so friends, if you like this video, please press the like button and subscribe to my channel PSU Aspirants.